All right, Sex and Math, Course 2, Lesson 86. Today we are in Lesson 86, which deals with something called number families. Okay? Number families are basically, there are four different number families, and to just qualify what a number family, it's different ways to solidify a type of number. Uh, you might not see this until we start working on this. So let's just begin with the first one here. We'll call this A, and let's look at something called counting numbers. Okay, every time I teach this, a counting number is like what you do when you start counting when you play hide and seek. Remember when you played hide and seek and everybody said, okay, so and so's it. All right, Jeremy, you're it. So count to 20. Everybody goes and hides. Okay. When I counted, I started with 1, 2, 3, 4, 5. I started with 1. I didn't get to the tree or, hide my head my lap and say 0, 1, 2. No, I started with 1. Okay, so counting numbers are all positive numbers, not including 0. So 0 is not part of a counting number. So just think hide and seek. When you hear counting numbers, hide and seek. 1, 2, 3, 4. Okay? Whole numbers are counting numbers that include 0. Okay? How do I remember this? When I think of whole, I think of not this spelling, but I think of this spelling, like a hole in the ground, which looks like a 0. So, whole numbers, and you see the O here, include 0. So, 0, 1, 2, 3. But they're 0 through positive numbers are whole numbers, okay? All right, so integers would be the opposite of the counting numbers and whole numbers. So integers are all the negative and positive numbers, including 0. So -2, -1, 0, 1, 2 would be an example of those integers. Okay, and then rational numbers are anything that would have to do with a fraction or a decimal. Okay, so fractions or decimals on a number line, and you can hear rational, you can hear ratio right there, which means a fraction. Okay, now get this: 2 over 1 is a ratio, that is a fraction. So the number 2 actually can be part of those numbers. Okay, and it can be negative because you can have a -2 or a -1/2 or a -3/4 or whatever the case may be. So rational numbers can be very, very specific as well. So some of the questions you're going to get today, let me just review. So A, counting numbers, 1, 2, 3, 4, 5, hide and seek. B, whole numbers, 0, 1, 2, 3, 4, 5, and following. Integers would be negative numbers, whole numbers, okay? -2, -1, 0, including 0, 1, 2, 3. So it's negative, 0, and positive numbers, okay? And then D, rational numbers, dealing with fractions, decimals, ratios. All right, let's go to the example that you have in your textbook, example 1. And what they're going to have you do in this is to graph a number. Okay, so you need a number line, and it says this: graph the integers that are less than 4. Okay, so any integer that's less than 4. So if we put number 4 here, less than 4 means that we start with 3, 2, 1. Now it asked for integer. What is an integer? It is both negative, 0, and positive numbers. And if it's less than 4, that means we're going to put solid dots on every number that is this direction of 4, right? And it goes in this direction indefinitely, because less than 4 just means constantly through that direction. So what is our answer? Our answer is this right here. We graphed with dots colored in on all those numbers, and you can choose, okay, how many you do. You can go to 20 if you wanted to, but what I like to do is show some positive, 0, and some negative. Okay, technically I should go to -3 because I started with 3, just to demonstrate the full value of that. All right, but it goes in that direction. Okay, So example number 2 gives a similar question, but it says, answer true and false, all whole numbers are integers. All right, well, an integer is negatives, 0, and positives. So the question says all whole numbers are integers. Whole numbers would be from here following. Are those integers? Yes. So A has to be true. All right, B says all rational numbers are integers. Well, what's a rational number? A rational is a ratio. So, is that a picture of 3, 2, 1, 1, 2, 3, as far as negatives and zeros? No, a ratio is an actual fraction. We can't show an integer as a fraction. An integer has to be a number, a full unit. So this has to be false. Okay? Where do I get the answers for this? Like, how do I get a quick view of this? Okay? On page 594 on top, there is a big schematic, and it's got all these boxes, and it looks like this, and all these things are labeled. Okay, so you have rational numbers up here, you have integers, you have whole, and then you have counting numbers inside. Okay, this box is extremely helpful to answer these kinds of questions. Okay, and then graphing things, it's really easy because all you're doing is putting dots on numbers depending on what those numbers are, and based on what we talked about, counting numbers, whole numbers, integers, and ratios or rational numbers, you will know how to identify those very easily. All right, if you have any questions with this, it's a pretty simple lesson. Don't be afraid to ask, and I'll help you during class.